So in 5C, we learned how to multiply polynomials. And here in 5D, we're going to take a look at two different special products, we call them, special situations of multiplication. Neither of them do you need to know in Chapter 5 because we know how to multiply any two polynomials. The patterns we're going to look at here are more so in the sense that this particular pattern, this first one, will be very, very useful in Chapter 6. So we want to kind of be introduced to it here so we're ready to use it when we see it in Chapter 6. The other one, if anything, I'll say is more of a we want to learn it so we can avoid a mistake kind of a special product. But starting with this one, 5D1, it's called the product of the sum and difference of two terms. It's a very long name, not as long as the formula itself, but the specific pattern is summarized in that phrase. The product, the multiplication, of the sum and difference, the addition and subtraction of two terms, meaning the first two terms are the same and the last two terms are the same. It's a very specific form. This only would be the case if you run into a problem, such as the one below, where you've got x's, 3's, 1's a plus, 1's a minus multiplied together. That's a very specific pattern. But what we know, and this is kind of it multiplied out, what we know is that if you were to draw those four arcs, you get those four terms. A squared, negative AB, positive BA, and negative B squared from those four arcs. Now, this B times A, we know from multiplication being commutative, B times A is the same as A times B, and then we notice that we have a negative AB and a positive AB, which will always cancel, always take each other out, leaving us with just the A squared term minus the B squared term. So we know that this pattern results in this answer. Now, like I said, you do not need to know or use this right now because in a problem like these down below, you could absolutely just draw four arcs and watch those two middle terms cancel. There's nothing wrong with that. I do want to show you how you can use this formula just so you've seen it. And again, so that Chapter 6 can maybe help, be a little easier to grab hold of when we see this again then. So the idea is this pattern, when you see it, we say those are the same, those are the same, 1 plus, 1 minus. And the order of which one's the plus and which one's the minus doesn't make a difference. But what does matter is which one's A, which one's B. So A, in this case, is X, B is the 3. And so if you can identify this exact pattern, you can say that we know the result will simply be A squared minus B squared. And so A squared, if A is X squared. B squared, if B is 3, would be a 3 squared. And so all you'd have to do is say 3 squared is 9, and there's our answer. The same exact answer you'd get if you distributed all four arcs and watched those middle terms cancel. Okay? So one more example of that. Again, just reinforcing this pattern. We've got those are the same for A, those are the same for B, one's a plus and one's a minus. So in this case, A is 2x and B is 5. And so if we go to fit them into our formula, A squared is 2x. Now here, be careful, absolutely have to use parentheses here. Square A, square all of 2x, and square 5. Now, squaring 2x, this right here is officially the power of the product, right? 2x is 2 times x. This is the rule we just learned earlier in Chapter 5. When you square 2x, it's like squaring 2 and squaring x. Or another way to think of it is just 2x times 2x, right? 2 copies of 2x. That would give us 2 times 2 is 4, and x squared. So whichever way you think of that, whether you think of it as the power of the product, or you just kind of think it out as 2x times 2x, you get 4x squared, and then the 5 squared is 25. And there's our final answer. But this right here, we're going to see on the very next page, we got to make sure we understand how to do this and when not to do this, if that makes sense. We're going to see something that might be similar to this, but is actually very different in section 5D2.